Hello everyone, welcome back to the channel. In this channel, we learn OpenShift, Kubernetes, Linux Administrator, DevOps tool, real-time production troubleshooting, and interview preparation. If you are preparing for Red Hat, OpenShift, or DevOps role, you are in the right place. Let's get started. Today we are see what are the Kubernetes services and its type. In Kubernetes, pods can be created, deleted, or restarted at any time, and their IP addresses can change after the pod restart. The Kubernetes service provides a fixed IP address and DNS name so application can always find and communicate with pods without worrying about changing the IP address. It also helps distribute traffic across multiple pods using load balancing. Now, in short, when you are working in the Kubernetes, do you aware about this when you create, delete or restart the pod at any time or any number of days? So that time you analyze your pod IP address has changed. So that time you know about when you restart the pod, that time your IP address has changed. In Kubernetes, there are the services to provide a fixed IP address and DNS name. With the help of this, your application can always find and communicate with the pod without worrying about any IP address change. So these are the beautiful feature present into the Kubernetes or into the OpenShift. Now let's talk about the services and its types. What is Kubernetes services? Kubernetes service is an abstraction layer that provides a stable network endpoint to access the pod. What is Kubernetes service? It is a stable network endpoint to access the pod. Why service is required in Kubernetes? Pods are inferable. Pods IP changes after restart. Pods can be created or deleted anytime, and application need stable communication. That's why the services is required inside the OpenShift. What are the Kubernetes services or what are the OpenShift services? They provide us, they provide stable IP address, stable DNS name, load balancing, and service discovery. So these are the services OpenShift providers. Now we talk about the services. With service and without service, what happen? Suppose you have the front end pod and that front end pod communicate with the back end pod. Here we saw there are two back end pod. Pod 1 that IP address is 10.0.0.5. Pod 2 that IP address is 10.0.0.9. Suppose that pod restart, front end cannot connect to the back end pod. Why? Because without service, the pod cannot connect or cannot communicate with each other. Suppose you have the services. When you have the services, front end pod connect to the backend service and then backend service connect to the backend pod. Why that pods communicate with each other? Because into the backend, front end backend, we configure the backend services. With the help of this service, that front end pod communicate with the backend pod. How OpenShift or Kubernetes services work? They are work with the component that involve inside the OpenShift. That is pod. First is pod, application container running. Second is label, used to identify the pod. For example, label. In that label, you found the app and tier. App means your application name and tier means that pod is your front end or back end pod. Then service. Select pod using a label. Then fourth is kubeproxy. Kubeproxy implements service on each node using IP tables and IPVS. Then DNS. Provide service discovery with DNS name. These are the five components OpenShift services work. How the request flow work when you are using the services. Suppose client send a request to a service IP or a DNS. Then kubeproxy receive the request. Then kubeproxy load balances to one of the healthy node. You can see here once that request reach to the kubeproxy, then kubeproxy load balance to that service and it send to the healthy node. Then response goes back to the client. So these are the four steps when pod communicate when client communicate with the pod or any request client send to the pod. Service discovery. Every service get a DNS name automatically. So this is the beautiful feature of the service. Example, backend-service.default.svc.cluster.local. You can find the service discovery or DNS name like the example. Now we are talking about the service type. There are five service type present inside the OpenShift. Even though you can find the same service name inside the Kubernetes. First is cluster IP, second is node port, third is load balancer, fourth is external name, and fifth is headless service. Now we are seeing the first service, cluster IP, that is the default service. Expose the service on a cluster internal IP, accessible only within the cluster. This is the default service type. Means, in short, To use pod to pod communication, we are using the cluster IP. This is the default service type when you create any new pod. Then talk about the node pod. Expose the service on each node IPs and service static port. That port number start from 30,000 to 32,767. Accessible from outside the cluster. Why we use the node port? Because if you want to access any service from the outside the cluster, you have to give the node port. How that node port work? Service, that service name is node port, and what port you have to assign? You have to assign the port from 30,000 to 32,767. So here we give 30,080. With the help of this node port, you can access your application outside the cluster. Third is load balancer. What load balancer do? Load balancer expose the service externally using cloud provider's load balancer. Cloud provider provision an external IP. Load balancer use the external IP. Then services use the load balancer, and that request reach to our pod. So load balancer we can use the cloud providers, and that cloud providers point to our service load balancer. Then external name. External name maps the service to external DNS name. No proxy, load balancing here we use. Used to access external services. Like service name, that is external name, like my-db.example.com. These are the service name. We have to configure the service name inside the OpenShift, and with the help of this name we can access your application. Headless service. Service with cluster IP is equal to none. Does not allocate cluster IP. Return pod IPs directly. Use for stateful say use for stateful set DNS discovery. Means if you are using the headless services, that headless services does not use the cluster IP. It use the pod static IP that you are given to that pod. So these are the five types of the services. Now we can see the quick comparison of the services. Type of cluster IP. Use cluster IP, not using external access, but it use the load balancing. Why? Because it use the internal communication within the cluster. Node port. Node port also use the cluster IP, also use the external access, and provide the load balancing. What are the use case? The use case of the node port: external access via node IP and port. Then the load balancer. Load balancer also use the cluster IP, external access, and load balancing. It use external access via cloud load balancer. Then external name. External name cannot use the cluster IP. It use the external access via DNS. It not provide the load balancing. The use case of the external name access external DNS services. Then fifth is headless. It not use the cluster IP. It use the pod IP for external access. Not provide the load balancing. The use case is stateful set and service discovery we are use. Then here one sample example YAML file for the cluster IP. In that YAML file we see API version, kind, what kind do you require? We require the service. This is kind or our type. Then metadata. Inside metadata, we define the name that pods belongs to the backend service. Then spec. Inside spec, we give the type, which type we have to give. We give the cluster IP. Then selectors. Selector is defined our application pod name. What is our application pod name? That is my app. Then define the ports. My source port is 80 and my target port is 8080. So these are the sample service YAML file point to the cluster IP. The remember always access pod through the services, not directly by pod IP. Make sure your application resilient and scalable. Then fifth step is the common command in OpenShift. What are those common command? The command is OC get SVC. With the help of this command, you get all services, the list all services in the current namespace with the help of OC get SVC command. Then OC describe SVC service name. It describes the service, shows detailed information about the specified service. Then OC get SVC service name hyphen O YAML. It gives you the service YAML file detail. Display the service definition in YAML format. And last one is curl http colon double slash service name namespace dot svc dot cluster dot local. Access the service inside the cluster. Means access the service using internal DNS name for inside the cluster. With the help of this command, you can found any service related issue inside the cluster. Keep remember those command. It is very helpful when you face any service related issue inside the OpenShift. Now the benefit of that services is provide stable endpoint for the pod, enable load balancing, support service discovery via DNS, decouples application from infrastructure, works across multiple pods, and last is improve scalability and availability. So these are the benefits when you are using the service inside the OpenShift. How service access works inside the cluster? See, there is one pod that is your client. That client access the URL, and when you access that URL it goes to your services, and that service is called to your application pod. Here the internal DNS name resolved to the service IP, which routes traffic to the available pods. So this kind of pod work into the background. Now take a look of the scenario based question. Suppose user complain or send any mail regarding a pod stuck in pending state. Then how you can approach to troubleshoot this issue? A developer reports that a pod is stuck in pending state. How would you troubleshoot? First, you can check OC gate pods. Which pods went to pending state? Then you check that pod with the help of OC describe pod and pod name. So inside this pod, you get the event session, and when that pod goes to pending state, so there are few events we have captured here, that is insufficient CPU, insufficient memory, PVC not bound, node taint, and no worker nodes available. So these are the common reason when pod stuck into pending state. You can see like this in example 0/6 nodes are available, insufficient memory. Like this you can get the message inside the event section. Then after that you have to verify OCADM top nodes, and also you have to verify OC describe node and node name. With the help of this command, you can find out why your pod going to pending state. The interviewer answer is first, I check pod events using OC describe pod command. Most of the pending issues are caused by resource shortage, PVC binding problem, or scheduling the constraint. You can give the answer when your pod going to stuck. Then second scenario is application suddenly down. User cannot access the application. What will you check? First, you check OC gates route. Then you check OC gate service. After that, you can check the endpoint with the help of OC gates endpoint, and then check the pod OC gate pods. These are the four commands. Is very useful when your production application suddenly down. In that you can see like this endpoint is none. Endpoint is none means service selector does not match the pod labels. That's why the your application is suddenly down. Means application pod is suddenly down. To fix this issue, you have to check OC describe SVC and your service name and check OC get pods hyphen hyphen show label. You can find out is your label is right or wrong. If it is wrong, then you have to assign the correct label. Third scenario is PVC stuck in pending. Application deployment failed because PVC is into pending state. Then how do you troubleshoot that PVC going to pending state? First, we check OC get PVC command. With the help of this PVC, we can find out which PVC went to pending state. Then we describe that PVC with the help of OC describe PVC and PVC name. In that describe command, we saw the possible error that is no persistent volume available. After that, we check the storage class with the help of ocget sc command and then check the pv ocget pv. So to check why that pvc went to pending state, these are the commands we have to figure out why this happened. To fix the issue, first we have to create the pv, correct the storage class and verify the storage cluster. Then come to the fourth scenario, crash loop backup. In generally, lots of people facing the crash loop backup error into the application pod. So here are the some basic steps we have to follow and find out why this crash loop backup happens. Now the fourth scenario is application pod is restarting continuously. To resolve this issue, first we check with the help of ocget pods command. In that command, we see that pods continuously going to the crash loop backup after restart. Then we first check that pod related log with the help of OC logs pod name. If you not found anything inside that log, then you can check the previous log with the help of OC logs pod name hyphen hyphen previous. The common reason is wrong DB connection, missing secret, application error, and insufficient memory. Fifth scenario is image pull backup. Pod cannot pull image from the registry. How do we check? With the help of OC describe pod name. With the help of we can check the image pull backup error. Then we verify the secrets, that secret is right or wrong with the help of OC get secret command. Then check the pull secret with the help of OC describe secret default. In that default secret, we can see the common error that is wrong image name, image registry unavailable, missing image pull secret, and authentication failure. So these are the common reason we have to face when image pull backup error comes into the pod. Then scenario number 6. Master audit logs not visible in Grafana. Means audit logs are not appearing in the Grafana dashboard. How do we check? First, we check the cluster forwarder with the help of OC-get cluster log forward command. Then verify the locky pods with the help of OC-get pods -n OpenShift login. In that login, we cannot find out any pods into pending state, image pull backup, or crash loop backup. If you found these kind of errors, that time your logs not appearing into the Grafana dashboard. So it will be always in ready state. Then check the collector pods with the help of OC logs and your collector pod. In that collector pod, we have to verify the pipeline, that is input reference -audit. If you miss this pipeline, then your log also not appearing into Grafana dashboard. This is very important to send the audit log into the Grafana dashboard. Then scenario 7, ODF storage issues. ODF storage issues basically belongs to PVCs. PVCs are not getting provision in ODF. How we check? We check first OC get storage class. Then we check the ODF pods is ready or it's showing any errors with the help of OC get pods -n OpenShift storage. With the help of this command, we see our pod status. Then we check the safe pod with the help of OC get safe cluster -n OpenShift storage. With the help of this, we can find out our safe cluster pod is properly running or not. Once we check all the possibilities, then we can find the common error why that provisioning failed, because OSD pods running, mon pods healthy, storage cluster healthy. This possibility we have to check. Even though that possibility of the pod is not running, means we face the previous provisioning failed issue. Then scenario number 8 is route accessible internally but not externally. How we can check? Application works inside the cluster but user cannot access from the browser. Coming to the number 8 scenario, route accessible internally but not externally. How? Take a look. Application works inside cluster but user cannot access it from browser. For that, first we check the route with the help of OC-get route command. Then verify the ingress pod with the help of OC-get pods -n in OpenShift ingress. Then test the URL with the help of curl-vk https://route URL. So after that you can find the common issues, that is DNS missing, router pod down, firewall block, or TLS certificate expired. These are the common issues we face when we not accessible the URL from the browser. Then scenario number 9. etcd disk use reach 85%. That is the P1 alert. Production alert shows etcd disk usage as 85%. What step will you take to troubleshoot and fix it? First, check cluster health. Make sure all cluster operators are healthy with the help of ocget co command. Then check etcd status with the help of ocget pods-n OpenShift-etcd. Then perform the second step, identify which disk is full. Log into the affected control plane node with the help of ocdebug node master node name. Then use chroot-ost and check with the help of df-h command. Check etcd directory use with the help of du-sh where lib etcd. With the help of this command, you can see how many space etcd taken. Then step number 3. Check etcd database size. Find etcd pod with the help of ocget pods-n OpenShift etcd. Connect to etcd pod with the help of oc rsh-n OpenShift-etcd and etcd pod name. And after that, you can check the db size with the help of etcdctl endpoint status -cluster -w table. Then look for db size. If db size is growing continuously, compaction may be required. Once we check the database size of the etcd, then we perform the fourth step, that is check for old etcd backup. How we can check? First, we check one of the master node with the help of ls-lh command, home, core, asset and backup. Or you can use the find command if you doesn't know the path of the backup. After that, if you see any old backups, then you can remove that backup with the help of rm old and then backup name. Then fifth step, check etcd alarm ocrsh-n OpenShift etcd and etcd pod. Check the etcd-ctl alarm list. Possible output you get, that is no space. This indicates etcd storage exhaustion. Then perform the step number 6. Defragment etcd if recommended. Check defragmentation with the help of etcd-ctl endpoint status -cluster-o table. Perform defrag one member at a time with the help of etcd-ctl defrag. Then verify size of reduction, that is etcd-ctl endpoint status -cluster-w. But the one important point is, in production, follow Red Hat procedure and perform maintenance carefully. Then perform the 7 number step. review etcd log. How we can review the etcd log? With the help of oclogs-n, OpenShift, etcd and etcd pod. Look for database space exceeded, MVCC database space exceeded, or no space alarm. So these are the events you have to find out inside the etcd log. Then check Red Hat recommended limits. How we can check the Red Hat recommended limits? Check current etcd database size, etcdctl endpoint status hyphen cluster hyphen w table. A rapidly growing database may indicate excessive API object, large number of events, stale resources, and login or monitoring overload. So these are the 8 steps when your etcd database reach to 85%. If anyone asks this question into the interview, then you have to say, first I verify cluster and etcd health, then I check disk use on control plane node, review etcd database size, look for old snapshot or backups consuming space, check for no space alarm, and verify whether etcd defragmentation is required. If fragmentation is high, I perform etcd defrag following Red Hat best practice and continuously monitor cluster health before and after the activity. So these are the simple and sweet answer. Thank you for watching this video. If you found it useful, please like, share and subscribe to the channel. Don't forget to press the notification bell so you never miss upcoming videos in OpenShift, Kubernetes, Linux and DevOps. See you in the next video. Thank you for watching. Bye bye.